Okay, now we're going to do some problems concerning linkage mapping. These will be dihybrid crosses. One of the things that you'll need to tell me concerning these, in addition to the map distance, which I'll show you how to get in a minute, is the allelic configuration, which is drawn there. And cis or coupling is another word for cis, and trans or repulsion is another word for trans. So in cis, both dominant and both recessive alleles are on the same homolog. So these little lines here represent small portions of chromosomes because, again, we're studying linkage and these genes are very close together. So big A and big B on one, little a and little b on the other homolog, that's cis. Here we've got big A, little b on one homolog, little a and big B on the other. This is trans. One dominant, one recessive allele on one homolog, one recessive, one dominant allele on the other homolog. Okay, and now I'll show you how to do a couple of problems and how to determine cis versus trans. Starting the parental generation. It's a wild type fruit fly. So wild type is always given by the plus for the allele, and it is always dominant. And we'll cross it with a fly that has purple eyes and vestigial wings. Wild type wing color, wild type eye color, excuse me, is red, and vestigial wings just means little tiny crumpled up wings that don't function. All right, the F1 generation then, of course, will be wild type because they get a plus allele from each parent. So the genotype will be plus P, plus V, and their phenotype is wild type, abbreviated WT. So then what we do is we take an F1 female and perform a test cross. And by the way, these are called 2-point test cross. 2-point meaning 2 genes. There are also 3-point ones, but we're not going to do those this semester. Anyway, so we take our F1 female and we cross her with a tester male, and that means homozygous recessive purple vestigial male. And then let's see what the F2 flies look like, and from the F2s we'll get our data to do our map. So what I'll do is put the females contribution across the top and the males across the bottom. So we have kind of a modified Punnett square. Like this. Have to make some more room there. So all of Dad's gametes are purple and vestigial. And then, of course, the female, being a heterozygous dihybrid, will produce 4 types of gametes: wild type, purple vestigial, vestigial, and purple. Now, they won't all be in the same numbers because, again, we're dealing with linkage here, so parentals will be in high numbers, recombinants in low numbers. And let's see what's in each group here. So in this box, we've got wild type offspring. This box, purple vestigial offspring. This box, vestigial offspring. And the last box, purple offspring. So let's add some phenotypes, and then I'll give you the data. So PV just means purple vestigial. Remember, we don't mention wild type, it's just understood. We just identify them by what recessive trait they show. Okay, now the data. So we have 1339, cute little wild type flies. 1195 purple vestigial. 151 vestigial. And 154 purple. Okay, so these numbers will be given to you. You just need to know what they mean and what to do with them. So we can see here that the first two are much higher numbers than the second two. So these first two then are the result of no crossing over. So these kind are called the parentals. And then vestigial and purple are in smaller numbers, so they've resulted from a crossover. And so these are called the recombinants. Just that a little bit there. So parentals in high numbers, recombinants in lower numbers. So what's going on here? And in our one female, that is this individual. She had a genotype like that. And so a single crossover then occurring between these two would result in recombinants being vestigial in purple. So there it is. 151 of these, and you can see 154 of those. Now, this really isn't part of the problem. I'm just doing this to show you how the recombinants were created, if you will. So now our next step is to calculate the map distances with them, which is just the recombination frequency expressed as a percentage. So let's do that. So I have to erase some of this stuff, make some room. So if we add up all our number of flies, we have 2839. So these four groups add up to 2839. And so our map distance is merely our number of recombinants divided by the total number in the data set, multiplied by 100 to make it a percentage, and that is our map distance. So we can see here we've got, looks like 305 recombinants. 305 divided by 28, 39 flies times 100 gives us a 10.7 map units or centimorgans apart. So that means there's about 10% or almost 11% recombination between the purple and vestigial genes. So then our map itself looks something like this. Purple, vestigial, 10.7 map units. So this then is our linkage map of these two genes. And now we need to determine the allelic configuration, where we look at the F1 females allelic configuration here. And we see that the parental gametes are wild type and purple vestigial. And I already wrote this up here, but I guess I'll do it again. Dominants on the same homolog, both recessives on the other homolog, and this shows that this is a cis or coupling configuration. So that's all we need to do, figure our map distances and our allelic configuration, and that is all concerning that problem. I'm going to do one other problem. Sometimes they will give you the map distance and ask you to figure out the data like we have down there, so sort of working backwards. So giving you this and asking you for that. Okay, that's what we're going to do in the next problem once I get the board erased here. Let's see if I can move this over this way. Okay. Okay, so here's that problem. We have the genes for vestigial wings, V, and cinnabar eyes, CN. They're 10 map units apart. That means 10% recombination between them. And our parental cross is crossing a vestigial female with a cinnabar male to yield an F1 that is wild type, but of course heterozygous. So what the problem is asking us to do is to figure out how many gamete types will be produced and in what proportion will they be produced in. And secondly, to conduct a test cross with this F1 female times a tester male to determine how many offspring will be produced and in what proportions will they be produced. So let's go ahead and start with A here. And I might be able to squeeze it in over here. So again, the horizontal lines represent parts of the homologous chromosomes, and the little cross hatches the genes. So we've got a vestigial chromosome and a cinnabar chromosome. And if there is 10% recombination between them, that means this happens 10% of the time, and this will yield then 5% wild type gametes, 5% vestigial cinnabar gametes. Those are the recombinants. Okay, and then the other 90% will have to be the parentals, and so half of 90 is 45, so there's going to be 45% vestigial and 45% cinnabar gametes. So these are the 4 gamete types and in the proportions that they're produced. So again, these 90% are parentals, the top 10% are recombinants. So that's the solution to part A. Now part B, we're going to do that test cross and see what kind of results we get there. And I will attempt part B here if there's room. I think I'll erase some of this stuff just to give me a little more room. And both these genes are in chromosome 2 in fruit flies, by the way. And so in B here, we would have our female F1, who's going to be plus V N, crossing her with a male tester, and that looks like that should fit. Vestigial cinnabar homozygote, and the male, I'll put his there, and then with the female, CN. So that's how we'd set up our modified Punnett square, if you will. So here we get that. Okay. This one. Okay, so again, the male parent's contribution is on the bottom, and he's a tester, so he's not going to create any more phenotypic categories, but it's the mom on top there. And so these first, of course, are vestigial, and they are parentals, so that's 45% of them. Second are cinnabar. They're also at 45%. Then here we've got our vestigial and cinnabar offspring. They're at 5% because they're recombinants. And lastly, here we've got wild type, which are also at 5% because they're recombinants. So recombinants, and then down here are the parentals. For that messiness, but the computers only picks up so much. So we've got 10% recombinants here, vestigial cinnabar 5%, wild type 5%, and then 90% parentals, 45% vestigial, 45% parentals. And that's how you do a cross like that. And that's all I've got for the problems for chapter 7, which again are due at the end of the week.